Hello and welcome to the section 9.2 lecture today. Today we're going to kind of formalize what we sort of came up with yesterday, some of the basic ideas that we came up with yesterday, and hopefully get them into something that's worthwhile. If you remember from yesterday, we did a problem like this, and we had to expand it. 2, 3, 4, and 5. And then we got to condense it back down. Since they were all 2's, I can combine them all and say it's 2 to the 8th power. Well, the question is, how do I use 3 and 5 together to give me 8? Obviously, the 2 has stayed, but the two 2's kind of became 1, 2, So how do I combine the 3 and the 5 and get 8? There's only one way. No, there's not. There's multiple ways. But the most basic way is that I add those two. So the rule is if I have any number to the m power times that same number to the n power, that would actually be equal to a to the m plus n power. So instead of writing out all those expansions, we should be able to do this without. Let's take a look at how we do that. 5 to the 3rd times 5 to the 6th turns into 5 to the 3 plus 6, which is 5 to the 9th. Much easier. At least I hope so. X to the 2nd times x to the 3rd times x to the 4th turns into x to the 2 plus 3 plus 4, which would be x to the 9th. This next one, I have a 3 and a 7. Those are just going to be separate. I'm just going to call those 21, because 3 times 7 is 21. And then I have b to the 2nd plus the 4th. So 21b to the 6th. Down below, we have some slightly harder ones. I have a 2, a 3, and a 6. I'm just going to multiply those together. A lot of times with the numbers, if I don't see anything repeating, I don't stress about it too much. Okay, so I have a 2, a 3, and a 6. We'll just multiply those together. 2 times 3 is 6, and 6 times 6 is 36. So there was an easier way, but oh well. We could have said 6 squared, or 2 squared times 3 squared. But I'm not that worried about that. A-wise, I have a to the 3rd plus the 5th plus the 2nd. That sounds to me like 36 a to the 10th. Next one, I have a 3 and an 8. 3 times 8 is 24. X to the 4 plus 2. And y to the 5 plus 7. Looks like 24. X to the 6th. Y to the 12th. Last one, I do have two 12's there. I can go ahead and call that 12 squared, because 12 to the 1st plus 1st, 2 12's. A to the 4 plus 8, B to the 12 plus 32. Thank you. I do not have to write out 32 B's after writing 12 B's. That's a good thing. There is a quicker way. I have a to the 12th and b to the 44th. Thank goodness I didn't have to write all those on that one problem. Again, same idea yesterday. We talked about the exponent of an exponent, and we said that was 2 times 2 times 2 to the 5th power, or I don't know why I chose such big numbers. Like 5. I know it's a big number. There's 2 of them. There's 3 of them. There's 4 of them. And there's 5 of them. How many 2's do I have in total? If you do the math, if you do the counting, it feels like 15. 15 twos. And how do I combine 3 and 5 and get a 15? There's one good way to do that. It is multiplication. If I have any number to the m power, then raised to the n power, we get that with multiplication. M times n. So we can take care of all these problems that same way using a multiplication rule. Well, we call it the power rule, but in the power rule, we use multiplication. This is going to turn into 4 to the 12 times 5th. Good thing I don't have to do that because that's 64s. 4 times itself 60 times. Yeah, I don't want to write that. This one's going to be 12 to the 3rd times 12, which is 12 to the 36th. The next one, I have negative 7 to the 15th, then raised to the 5th. Yeah, there's multiple sets of brackets here, but all that's trying to say is let's make sure that we know we have negative 7 to the 15th, and then we're going to raise that to the 5th power. 15 times 5 is 75. So we have negative 7 to the 75th power. Thank goodness I didn't have to write 75 negative 7s. And here we get even worse. X to the 14 times 14. If you know your times tables really well, that's 196. When I have multiple things in parentheses, okay, we haven't really looked at that in these ones yet, but I remember from yesterday that I'd have to write 10 and then, negative 10 and then 6 x's, and then I'd have to repeat that 4 times. So it sort of distributes, okay, to where I'd get negative 10 to the 4th, because 1 times 4 is 4, and x to the 24th, because 6 times 4 is 24. I did skip a step there. I'm going to continue to do that. This one I have a fraction, but I still want to think about distributing that power to everything in there. Anything without an exponent is automatically 1. And now I can't see what number I'm distributing. It's a 3. So I'm going to have 1/4 to the 3rd, x to the 6th, 2 times 3 is 6, and y to the 3rd, 1 times 3 is 3. In this one, I'm trying to deal with the quotient rule, and it came from this, where I had 2 times 2 times 2 times 2 over 2 times 2 times 2. And yesterday we ended up crossing out pairs on the top and bottom, and then writing what we were left with, where we said, okay, well, we've got 2 to the 2nd power. Now the question is, how do I use 5 and 3 to get 2? Namely, how do I use 5 and 3 to get this top 2? Well, there's one good way I can think of, and that's subtraction. If I have a or any number to some power over that same number to a different power, that would be the same as a to the m minus n. So 2 to the 11th over 2 to the 5th is going to be equal to 2 to the 11 minus 5, because the 5 on the bottom are going to cancel with 5 of them on the top, leaving the remainder left over, or 6. 6 of them left over. This one's going to be negative 4 to the 7 minus 3. 7 minus 3 is 4, so we have negative 4 to the 4th power. And last of the easy ones, I'll say, I have x to the 5th over x to the 3rd. So that's going to be equal to x to the 5 minus 3, which is the exact same as the first problem we had. except for x instead of 2. Okay. Now, if we look at some more complicated ones, we really just want to do what we can with the numbers. If I can reduce numbers, I should reduce numbers. Okay, so in these ones, 3 over 12 is going to reduce to 1 over 4. So I'm going to have 1 on top and 4 on the bottom. And then exponent-wise, 11 minus 3 is going to give me 8. On the top, I'll have y to the 8th times 1. I don't really need to write that. All the ones on the bottom cancel out, but I have a 4 on the bottom. Okay. Next one, 49 over 7 is 7. 7, x to the 7th over x to the 6th is x to the 1st. I don't have to write that 1. And y to the 12th over y to the 5th is y to the 7th. Pretty quick and easy. On this one, I know that I'm going to have 2 over 6 is 1/3. So I'm going to have a 1 on the top, 3 on the bottom. I'm going to kind of do some scratch work here to make sure I can keep everything straight. X-wise, I have x to the 9th over x. That looks like x to the 8th. 9 minus 1 is 8. Y to the 4th over y squared. 4 minus 2 is 2. And z to the 5th minus, or over z to the 4th. 5 minus 4 is 1. So I get that. Another way I could write that would be x to the 8th, y squared z, all over 3. Okay, now just to talk about it really quick, Pemdas, what we usually use as order of operations, has a weird, kind of a weird application to exponents. In that, if I see an exponent raised to an exponent, I multiply. So those two are kind of grouped. If I see multiplication in a problem, like 2 to the 3rd times 2 to the 4th, I would add. And if I see division, like up here, I will subtract. Okay. Yeah, there's really nothing special about these problems now that I think of it, but that's okay. We can still do it. I'm not really sure what I had planned on this one. So I have just 2/3 to the 3rd power. I guess one thing I do want to mention is that that will be equal to 2 to the 3rd power over 3 to the 3rd power. That might be something worthwhile. And on this one, I still want to do that same thing and think about, all I did there was kind of distribute the 3 to the top and bottom. I want to do that same thing here. Okay, I want to take that 4, put it on the 2, put it on the x, and put it on the y. Now y squared to the 4th power is going to be y to the 8th. Last little thing we'll talk about, some bring the pain problems. There's a lot going on here. Take it one step at a time, do what you can, try to get rid of parentheses first, and then slowly just chip away at what you have. I'm going to deal with each set of parentheses first. I'm going to think about distributing this exponent of 3 to the 2, the 3, and to the 2, the a, and the b, I guess. Using multiplication. 2 to the 1st times 3rd. 1 times 3 is 3. 3 times 3 is 9. 4 times 3 is 12. I am going to rewrite 4 here. I'm going to rewrite 4 as 2 squared. So I think that would help. And then I have a to the 1st. I'm actually going to write that as a to the 1st and b to the 5th. On the bottom, there's not much to do, but 64 is an exponent of 2. I believe it's the fifth. We have 2, 4, 8, 16, 2, 4, 8, 16, 32, 64. Okay, sixth. So 2 to the sixth, a to the fifth, b to the third. I want to do a little more cleaning up on the top. I'll have 2 to the fifth. Double check that. Oh gosh. Yeah, that's right. Okay. I'll have 2 to the fifth because 3 plus 2 is 5. I was not checking that part. I was checking the 2 to the sixth being 64. A to the 10th, I realized what that sounded like. That's okay. And then B to the 17th. Then on the bottom, I have 2 to the 6th, A to the 5th, B to the 3rd. Now I have some division. Now what I do when the top is smaller than the bottom, and that's exponent-wise, I kind of do it backwards. I kind of actually think about expanding it than condensing it. In that I'm going to have 5 2's up here, 6 2's down there. So I'm guaranteed to have a 2 on the bottom. There's one extra 2 that I couldn't cancel out up there. Okay, and then A-wise, I have 10 and 5. 10 minus 5 is 5. B-wise, 17 minus 3 is 14. And that's what we're left with. But that is a lot simpler than what it started out as. The next thing I have is a huge kind of exponent distributive problem. I want to put that 2 on absolutely everything. So I'm going to have negative 2 squared. M already has a 2. 2 times 2 is 4. N has a 3. 3 times 2 is 6. The multiplication doesn't faze me. I'm just working with it. 3 squared. M has a 9, and I'm multiplying it by 2, so that's 18. And n squared. On the bottom, I want to do the same thing. I want to pull that exponent of 2 into every piece. I have 3 squared, m to the 14th, n to the 4th. 2 times 7 is 14. 2 times 2 is 4. It looks like my 3 squared on the top and bottom would cancel out. So I can kind of get rid of those. Probably shouldn't have done that yet, but that's okay. I'm actually going to simplify the top a little bit, but getting rid of those definitely helps. M-wise, I have 22 on top. 4 plus 18. 6 plus 2 is 8, so I have 8 n's. And on the bottom, I have m to the 14th, n to the 4th. So, final answer-wise, I have negative 2 on the top. Negative 2 squared, I should say. 22 minus 14 looks like 8. So I have m to the 8th. 8 minus 4 is 4. And everything on the bottom would essentially cancel out. So hopefully some of that made sense. If there are any that you're unsure about, make sure you write that on this left side. That's what this line's here for. It's for you to put questions over there. Homework-wise, I would suggest you do 1 through 11 odd and application 1 through 5. We will work on most of those tomorrow, but we might not get to all of them. All right. Hopefully, or I guess the last thing is, I hope you have a great day, and we will see you in class.